let this be 4 farad. This is a charged, this is uncharged here. Then after closing switch, what will be the charge in both the capacitors? Then how much of it is generated in the circuit? This is C1, C2. Okay, look at the polarity plus minus. The initial potential is how much? Equal to 2 volts. So first we'll calculate what is that initial charge. So Q naught. So what is Q naught equal to? C1 into 2 volt. C1 is how much? 2 into 2, 4 coulombs. This was the initial charge in this capacitor. I'll close the switch. Then what will be the final charge in both the capacitors? So once after closing switch, what actually happens? A charge, because this is at higher potential, this plate is at higher potential compared to this. Here there's no charge, zero potential, and the positive charge will flow from higher to lower potential. So it will flow like this. How long this flow will occur? Till the potential of both the plates become equal. So we'll give some name for the plates. So let me give A, B, X, Y. So what is the condition arises here? VA greater than VX, VY greater than VB. So because of that, there'll be, once you close the switch, there'll be flow of charges here. Then what will be the final charge in the both the capacitors? So I'll assume plus Q1 minus Q1, Q2 minus Q2. Polarity of a capacitor here, because I given I know which is polarity, which is higher potential or potential. I myself give it. Practically you can identify. Okay, this will be plus Q2 minus Q2. So this is the thing. So how many unknowns are there? Q1, Q2. Okay, let's see what all equations we can write here now. So first, let me write loop equation. Already we know. Rather than saying both are at same potential, let me say loop equation, because this idea will help you a lot. So I'll trace out the loop. Plus Q1 by C1 minus Q2 by C2 equals 0. So I'm tracing the loop like this. I'll move from negative to positive plate. Plus Q1 by C1 minus Q2 by C2, all set equal to 0. So this should be equal to Q1 by C1, Q2 by C2. C1 is how much? 2. Q2 is 4. So Q2 is equal to 2 Q1. Okay, there's a one equation, we'll keep it. How many unknowns are there? Q1, Q2. I need one more. So I'll go for charge of isolated junction. You look at these two plates. What was the charge of these two plates? This plate was having charge Q naught and this is 0. This plate was having charge minus Q naught and this is 0. So charge of these two plates must be conserved. So from that, I'll write it here now. So or if you want, you can write J1, J2, anything. I'll write the sentence. Charge of plates A and X must be conserved. So what was the initial charge of this system? Q naught plus 0 is equal to Q1 plus Q2. Q naught value equal to 4. This will be Q1, 2 Q1. So Q1 equal to how much? It will be 4 by 3 coulombs. So Q2 will be, therefore Q2 will be 8 by 3 coulombs. Okay, this is about the charge in both the capacitors. What about any heat will be generated? Yes, it will be generated. Initial energy. There is no cell, no. But anyway, you stick on to the basic formula. Initial energy in the circuit, Q naught square by 2C1. There's no cell, so work done by cell 0. Final energy in the circuit, Q1 square by 2C1 plus heat. Solve this, there will be heat generated. So why that heat must be generated? Because I'm just taking help of the initial energy in the circuit. What is the initial energy? I'll calculate. Fine. Because of redistribution, heat will be generated. Sir, it must be, it may be. time being, we are going to do all the problems where we feel as if heat must be generated. So gradually we'll shift later next week some problems where heat may be generated. Will conclude at the end of the chapter. So what is H? H will be heat generated in circuit. Who will take this heat? Yes, it will be by conducting wires. Even the plates are conducting plates, no? Will be taken by the plates of capacitor also. Even these plates also can conduct. Even the plates also can conduct heat. So what about that heat will be taken by the conducting wires and also the plates also. Even the plates also, because plates are made up of conductors. So there also some heat will be generated. Okay, this is about what we did. This was not having any charge, no? The